Welcome. This podcast is going to be a virtual lab for our Unknown Molarity Marble Lab. I'm Miss Mikesell, and I'm one of the chemistry teachers at Eagle Crest. The essential question in today's lab is experimentally determine the molarity of a solution of hydrochloric acid, HCl, by reacting a given volume of HCl with a marble chip, calcium carbonate. Based on the theoretical molarity, calculate your percent yield and percent error. Explain whether or not your percent error is valid, plus or minus 10% of the true value. If not, identify possible error sources and explain how these sources affected your experimental molarity. So to start, let's write a balanced chemical equation for the reaction between aqueous hydrochloric acid, HCl, and solid calcium carbonate, which produces aqueous calcium chloride, water, and carbon dioxide gas. After you do that, determine which indicator of a chemical reaction you would expect to observe in this reaction. Pause the video and work on those two questions now. Hopefully for your balanced reaction, you got that 1 mole of solid calcium carbonate, CaCO3, will react with 2 moles of hydrochloric acid, HCl, aqueous, to produce 1 mole of calcium chloride, CaCl2, aqueous, and 1 mole of liquid water, H2O, and 1 mole of carbon dioxide gas, CO2. Because we see gas as a part of the products, you should expect to see the production of gas as an indication that the chemical reaction is occurring. Define molarity and give the equation for molarity. And then, using the meniscus, determine the volume of liquid in the graduated cylinder below. Be sure to measure the estimated digit for the correct amount of sig figs. Hopefully, you said that molarity is the amount of solute in a given volume of solution. And the equation for it is molarity is equal to moles divided by liters. Using the meniscus to determine the volume of liquid, well, remember that we always measure to the known and we have to estimate one place value past what we know. So we know that the bottom of the meniscus is between 4.4 and 4.3 and 4.4 milliliters. So we're going to estimate something between 4.3 and 4.4. We need to estimate the hundredths place. We could say our volume is 4.38 milliliters, and that 8 could vary based on other people's estimates. All right, our procedure for today's lab is to obtain and record the initial mass of a piece of marble rock, that's your calcium carbonate, and then place the marble rock gently in the beaker. Please don't drop it in and break the glass beaker. Circle which lab group number you've been assigned on your table below, because that will determine the volume of hydrochloric acid that you react. And then using the graduated cylinder, obtain the exact volume of acid. Pour acid from the beaker, then use the pipette to add drop by drop until the volume is exact. Be sure to measure the bottom of the meniscus. And then pour acid into the beaker containing the marble rock. Record your qualitative observations of the reaction occurring. And use the water bottle to do a quick rinse of the grad cylinder to move all the acid into the beaker. And then you can gently swirl the acid in the marble rock when you see the reaction to start slowing down. Wait for the reaction to completely finish, swirling occasionally and working on your lab analysis. When the reaction is done, decant, pour the solution into a 500 milliliter waste beaker while keeping the rock in the original beaker. And then pick up the marble rock with your fingers, using the water bottle to rinse the marble rock over the waste beaker 3 times. Then blot the marble rock with a paper towel. Blot means to just gently push down. Don't rub, because we don't want to lose any of the solid remaining. And use a hairdryer to blow dry it for 30 seconds so that there's no water on it. and then obtain and record the final mass of the rock. To clean up, you can pour all solutions down the drain, rinse glassware in the sink, and place upside down on a paper towel to dry for the next class. So you'll need to gather the following data: the initial mass of your marble, the final mass of your marble, and the volume of hydrochloric acid that you reacted. All right, let's take a second and get your virtual data set if you were absent on the day of the lab. So we're going to start by getting the initial mass of your marble rock. And you can see, please record that your marble has a mass of 10.370 grams. I've placed it gently in the bottom of the beaker. Now we need to get our hydrochloric acid. We're going to use group 1's volume of hydrochloric acid, so we need to measure out and react 25 milliliters of acid. We filled it most of the way up with the HCl. We'll add drop by drop so that we can get it right onto the line at this point. And remember, we do need to measure from the bottom center of the meniscus. So at this point, you would want to really make sure you're at eye level with the meniscus on the grad cylinder to get it right up to that 25 milliliter mark. We can see the bottom of the meniscus right there. Once we've measured out our volume, we're going to add it to the marble, and we can instantly see that reaction starting, lots of vigorous bubbling being produced. Then we're going to use a wash bottle to add in a little bit of distilled water to our graduated cylinder to make sure that we get all of the acid into the beaker. So we'll add that back in. And now we just need to have some patience. We need to let the reaction occur. We're gonna cut the video for a second until we get towards the end of the reaction, which should take 5 to 10 minutes. We can start to see the reaction slowing down, so we'll swirl occasionally to try to get that acid to move around in the beaker and find the calcium carbonate. We don't want to stop the reaction until the reaction is fully complete and no more gas is being produced. And now we'll decant. We're going to let all of the liquid waste go into our other beaker, but keep the rock in our original container. And we'll let it kind of slide into our hand so that we can capture and rinse that marble rock off. You should be able to clearly see what your limiting and excess reactant is. What was fully consumed in the experiment? What do we have extra of, unreacted? All right, now we need to blot with a paper towel. We don't want to rub because we don't want to lose any of the mass. And we're going to blow dry to remove any liquid water. so that when we get our final mass, it's accurate and it's dry and doesn't have any water as part of it. Last part of our data set is to simply put that marble onto the scale and get the final mass. And we can see a mass of 8.623 grams. All right, it's now time to do your calculations. Your job is to determine the molarity of the hydrochloric acid. Remember, molarity is moles per liter. You need to find the molarity of the hydrochloric acid, meaning you need to think about how you can transform your data into moles of hydrochloric acid that reacted and liters of hydrochloric acid that reacted. Once you know those two things, you can algebraically solve for the molarity. So you should be able to solve for moles using stoichiometry and then calculate the molarity based on the moles of hydrochloric acid that reacted and the volume that reacted. Once you do that, you'll answer the post-lab questions. Identify the limiting and excess reactant. Describe what would happen to the mass of the marble rock. And all lab groups poured their acid from the same beaker or source. What would you assume to be true about the group's experimental molarity of hydrochloric acid? Pause me for a second, answer these questions, and then we'll talk them through. So you should have identified that the hydrochloric acid was the limiting reactant. It was fully consumed. There was still unreacted marble, calcium carbonate, at the end of the experiment. It was in excess. As we saw, the mass of the marble rock decreased because some of it was reacted with the hydrochloric acid and produced calcium chloride, aqueous in solution, carbon dioxide gas, and liquid water. All of the groups poured their acid from the same beaker or source. So we should find that all of the groups' experimental molarity is the same. And that is because solutions are uniform, homogeneous mixtures, and the proportion of solute to solvent, the concentration, is the same. All right, the last post-lab question asks you to complete the table identifying possible errors would affect the mass change of the calcium carbonate and thus the molarity of the hydrochloric acid. Remember, molarity is the ratio of solute to solvent in a solution. Be thoughtful about how the mass of calcium carbonate will impact your molarity calculation. So, what would be the impact on the amount of calcium carbonate, and thus the calculated molarity of hydrochloric acid, if the reaction was not fully completed? Some of the HCl did not react before the student decanted. And how would the calcium carbonate mass and calculated molarity be affected if some of the marble was rubbed off while drying the marble? Pause me, please, and answer those two questions. If the reaction was not fully complete before we decanted, we would know that the mass of the calcium carbonate did not have as big of a change as it should have. So the change in the mass of the calcium carbonate would be lower than it should be because some of it did not react. And if we have a lower start to our stoichiometry, a smaller mass value for our calcium carbonate, we'll get a smaller value in terms of the moles of HCl that reacted, and that would give us a calculated molarity that's lower than it should be. Whereas if some of the marble was rubbed off while drying the marble, this would cause the change in mass of the rock to be greater than it should have been. Some of it would have been rubbed away instead of decreased through the chemical reaction. This would cause the ratio of solute to solvent to be off because we would have a higher mass of rock at the start of our stoichiometry, which would lead to a higher number of moles, and thus the calculated molarity would end up being higher than it should be. I hope this was helpful. Please reach out to your teacher if you have any questions and turn it in once you have it complete. Have a great day.